L71 for the 6th grade. Today we're going to continue our look at area of different types of shapes, and today we're going to focus on the parallelogram. Now if you remember our definitions of different quadrilaterals, we know that our first shape, 5 centimeters by 6 centimeters, is a rectangle. However, we also know that rectangles fit into the family of parallelograms. And so if I were to ask you to find the area of this one right here, we would probably pull out this formula just like this. Area equals length times width. So in the end it would be 5 times 6, which would give us 30, and then of course we'd put centimeters squared on there to give us an area. Then, if I were to ask you to find the area then of this parallelogram, would you be able to do that? And at first glance you might say, okay, I'll just do area equals length times width, right? And we'll go 5 times 6 and give us 30. However, as we look at this, parallelograms are a little bit different, because a parallelogram, because this slanted line right here isn't perpendicular, it's not technically a length or a width. And because of that, we have a problem that we need to solve. So how do you find the area of a parallelogram? Well, parallelograms end up being kind of neat things, because if we were to take a parallelogram like I have on the screen, and let's say we make this line right here, right next to the 8, we draw that line there. Basically we cut the parallelogram. Alright, so I cut it. Now I have this blue section that's free. Alright, and I move it over here like that. And then just for appearance sake, let me grab this, right? So where the red is, it's technically gone. Right? So I'll just hide that quick. Now if you look at the outline that is left, we have this shape. And of course you would say, wait, that's a rectangle. And that's true, it is a rectangle. And so in the end, what we can see from this is that a parallelogram, if we were to take that angled part off and move it over here, would give us a rectangle. And because we have a rectangle, we know that length times width works. And now we have a length up here and we have a width right here. But of course we're not going to see it like this normally. Normally we're going to see it just like this. And so how do we express this new idea? Instead we're going to see it like this. Area in a parallelogram is going to be base, right? That would be our 9 right here. Base times the height, right? This line right here. Because we can see how that relationship exists to create a rectangle. So now we can do base times height, or 8 times 9, which is going to give us 72 centimeters squared. And that's going to give us our area for a parallelogram. So that's idea number 1. Idea number 2 in this lesson is working more with parallelograms and the measures of their angles. If we know that angle R is 75, we want to know what angle P is. Now you might say, well, how do you find this out? Now earlier we learned that this angle right here is supplementary to this angle right here. Or in other words, they make a straight line of 180 degrees. So that would mean that this angle plus this angle right here should equal 180 degrees. Did I put these in the right spot? All right. Numbers don't really match what the angles look like, but the idea is still there, right? So this would be 105. 105. So if this is 105, S must also be supplementary to P, which would mean that P would be 75 degrees. And so in the end, we have that idea. The other thing we want to look at in this lesson is talking about naming angles, right? And so if we have this simple idea of angle P, right, this is angle P right here, dealing with this line and this line. It says give two other names for angle P. And so sometimes you can name an angle by one letter. Sometimes you need three letters to name an angle. So I can name it angle VPS, or I could also name this angle SPV. Right? As long as P is the vertex. That's the word I'm looking for, is the vertex. And so we have that idea. All right, that's our look at parallelograms. Here's some sample problems to get you working with area and also exploring naming angles in parallelograms also. That's lesson 71.